Dear students, see today we will continue in the revision of lesson number 1 and 2. Okay, that is electrostatics. Now see the some of the question based on the capacitance or capacitors. Now let us say okay. See we have to calculate equivalent capacitance between A and B. Now see in the language of the circuit, suppose I have a point called M. See there is no other component here, so this also is M. So in the language of the circuit there is a short circuit, or this capacitor is short. Okay, this capacitor. That means there is no importance of this capacitor C between same point. So our equivalent circuit will become like this. Now we can see between A and B, these two capacitors C and C are in series. Okay. So C equivalent is C1 C2 upon C1 plus C2. Okay, or series n capacitor of equal value are connected, then C equivalent is C by n. Here n is equal to 2. Okay, see we can use this in generalized formula. Okay, we can use this in a generalized formula. See n capacitor of equal value. Okay, n capacitor of equal value first connected in series. Okay. Now, in series connection of capacitor, we know that the equivalent capacitance will be smaller than the smallest. Okay, then it is divided by n, so value will decrease. And capacitor of equal value are connected in parallel. Okay, now we know very well. See in the parallel connection, see the value of the capacitance increases. So C equivalent will be NC into C max. Okay, suppose we have to find out value of the maximum and minimum capacitance. See C max we have obtained is NC. C minimum we have got C by L. So C max upon C min will be n square. So the n capacitor of equal value are connected first in series and then in parallel. See the ratio will become n square. Okay, so this can be useful to solve the formula MCQ based on this. Now let us take another example. Okay, see the question is like this. See there are 4 plates here. Okay, now the distance between each 2 plates is equal. Okay, we have to calculate the equivalent capacitance of the system. Now, see two things we have to keep in mind. These two plates should be consecutive plates. So we can say it will be 1 or 2, 1 and 2, then 2 and 3. We can take 3 and 4, we can take, but we cannot take 1 and 3. So this should be consecutive plate, okay, and one from the A and one from the B. Now what we can see here, see the points 1 and 4 are same. Why? Because the same plate is bent. So A is connected with the point 2, B is connected with the point 3, and 1 and 4 are our common points. Okay, 1 and 4 are the common points. So what we can say, here B is the distance between each two consecutive plates. So 1 and 2 will make a capacitor, while 1 is from A and 2 is a different point. Okay? See, this is formed. Now between 2 and 3 there will be capacitors. Why? They are from the different points. Okay? And 3 and 4. C and 3 are 4 also are different points. Okay? So what you can see, total 3 capacitor is formed. See, generally thumb rule is like this: if there are n number of plates, then it will be n minus 1 number of capacitors. Here 1, 2, 3, 4 plates. So 4 minus 1, 3 capacitor is formed. Now this capacitor is C, this is also C. Okay, these two are in series, so that will make C by 2 in parallel. So C equivalent will be. Okay, that will make values 3C by 2. Okay, and also C value is epsilon 0 A upon D. Okay, this is how we can solve. So there are a number of questions like this that you can solve. Now see the next question. Next is related to potential. Next is potential. Okay. Now 1 coulomb, 2 coulomb, 3 coulomb, and 4 coulomb are charged on the vertex A, B, C, and D of the square. Okay, we have to calculate potential energy of system of charges. Now, what is the generalized formula? U is equal to K Q1 Q2 upon R. Okay, that is a generalized formula for potential. So, see your potential energy between charge 1 and 2. You can take A, B, C, D as 1, 2, 3, 4, that will be easy for you. Okay, then 1, 2 is there, then will be 1, 3, then 1, 4. Okay, so these are the all combination of 1 and 2. Then 2, 1 is not required because potential is scalar. 2, 2 is not possible, so it will be 2, 3 and 2, 4. Okay, now see for charge 3, 3, 1 is there, 3, 2 is there, 3, 3 is not possible, simply U 3, 4. Okay, 1, 2, 1, 3, 1, 4 was done, 2, 3 and 2, 4. Why? Because 2, 2 is not possible, 2, 1 is already there. Then for charge 3, 3, 1 is there, 3, 2 is there, 3, 3 is not possible, 3, 4. Now we substitute, K is common. Okay, 1, 2, charge is 1 coulomb and 2 coulomb, distance is 1 meter. Then charge for 1 3 the charge is 1 coulomb and 3 coulomb. Now what is the distance between charge 1 coulomb and 3 coulomb? See, that will be diagonal. Also this is the hypotenuse of a right angle triangle. Okay, so this will be root 2. Okay, 1 4 will be 1 coulomb and 4 coulomb. Okay, then 2 3 charge is 2 coulomb and 3 coulomb. Distance is 1. 2 4 is 2 and 4 coulomb. It will be root 2. Okay, and finally 3 4 it will be 3 coulomb and 4 coulomb. Okay, now this we can simplify. K, it will be 2 plus 3 upon root 2 plus 4 plus 6 plus 8 upon root 2 plus 3 4 12. Okay, 2 plus 4 6, 6 plus 6 12 plus 12 24. 3 plus 8 upon root 2. Okay, K is 9 into 10 to 9. 12 plus 11 upon 1.41. We can write, simplify. So this is how we can calculate potential energy of system of charges. Now we can take another question based on the potential energy. That see 1 coulomb charge, 2 coulomb charge and 3 coulomb are on the vertex of an equilateral triangle of side 1 meter. See, they are to be shifted to a smaller triangle of 0.5 meter. Okay, what is the work done? Now this work done will be equal to change in the potential energy of the system. Now see, the first condition we can write U is equal to U12 plus, okay, that is K is common, charge is 1 coulomb and 2 coulomb, distance is 1, then 1 3, okay, 1 and 3, distance also is 1, 2 3, K, 2 plus 3 plus 6, 11 K. Okay, see, value of K will substitute at the end. This is the initial potential energy U1. See the final potential energy U2. See, charges are same, only the distance part is same. K 1 and 2. What is the distance here? 0.5. Then 1 and 3. Distance is 0.5. Similarly 2 and 3. Okay, now this will become 4 plus 6 plus 12. Okay, 22K. Now delta U is nothing but change in potential energy. U2 minus okay, this is how we can solve. This is regarded to the potential energy of system of charges. Now next is related to potential. See, the charges are Q minus Q, minus Q minus 2Q, 2Q and Q. Okay. Now see, the question says what is the relation between so that potential at center becomes zero. Now let us say L is the length of the square. See, the center square, all four sides are equal to the distance of all vertex from the center will be 0. So here potential is 0, V is 0, that is V1 plus V2 plus. Okay, let us say R is the distance, so it will be K minus Q upon R. This is the first charge, second charge, third and fourth. Okay, K into minus Q upon R, K into plus K into 2Q. Okay, now all this K and R we can cancel. Now see, 2Q minus Q plus 2Q minus Q is 0. Okay, so there is a relation between capital Q and small q such that the potential on the square becomes 0. So this is how we can solve. Now, three concentric shells of radius A, B, and C. Okay. Now, see, the surface charge density on the first is sigma, on B is minus sigma, and plus is sigma is the surface charge density. Now see the radius of the shell A, B and C. Okay, radius of the shell is A, B and C. Now we have to calculate potential at the center. Okay, now hollow sphere, all points at the center are just inside the shell are at the same potential. So here total potential will be V1 plus V2 plus V3. Here sigma is the surface charge density. So V1 will be KQ1 upon what is the radius A. Okay, similarly K into Q2 upon V. Now Q1 is a surface charge on the first wedge A square. Why? Sigma is Q upon area. Charge is sigma into area. Okay, here radius is A. So Q1 will be sigma into 4 pi A square Q2. See here sigma is negative 4 pi B square. Again here it is plus. Okay. Now if I substitute here Q1, Q2, Q3 value, K is common, sigma into 4 pi A square upon A, sigma minus sigma, that is given to us. Okay, see what we can see here. See, one of the A will get cancelled. Here, C will get cancelled. Now what we can take common? 4 sigma and 4 pi is common. What is left here? A, then minus B plus C. Now see, K is 1 upon 4 pi epsilon 0 sigma into 4 pi. Okay, so this is how we can calculate the potential at the center. Okay, now we take the next question. Now, see, there is a sphere of radius A, charge is Q1. Okay, see the sphere of radius B, charge is Q1. Now, when they are connected by a conducting wire, okay, see, we have to see how the charge will be distributed. How the charge will be distributed. Also, see, we have to find out the common potential. Now, when they are connected by conducting wire, their potential will become V1, 1 and 2. Q1 upon radius is equal to. Okay, now K is cancelled. Now we have to find out the charge on each sphere. See here, total charge will be Q1 plus Q2. Q1 plus Q2 will be. Now we take component of see what I have done, added denominator to numerator. See, Q1 plus Q2 is Q. So Q2 will be QB upon A plus B. Now Q1 plus Q2 is Q. Okay, Q1 plus QB okay, Q is common. Now let me simplify. Now, this is how distribution of charge will take place. This is how distribution of charge takes place. Now, we have to also calculate the common potential. Why? Because where they are connected by conducting wire, their potential become equal. So, let us say here V1 will be equal to V2, K, Q1 upon radius is A. Now, Q1 value we obtain Q into capital A, small a upon Same way, if I substitute in the equation for the V2 also, then also will get the same. So the total potential will be equal to common potential. Why? Because when they are connected by conducting wire, their potential is become equal. So V1 KO, that also will be V2 also. See, that also you can check. So this is how the distribution of charge take place. and their potential become. Now many times they give the some values, then we will be able to solve. Okay, so this is how we can solve for the system of charges. Now see how the energy distribution takes place. Now series connection of the capacitor voltage is divided and charge remains same. Okay, let us say ten volt battery. Okay, now we have to calculate voltage across each capacitor. Now in series connection, charge across each capacitor is equal voltage is divided. So here V1 plus V2 is V. Okay. Now see our formula C is equal to Q is V is Q by C. So Q upon C1. Okay. Now we can substitute the value Q. C1 value is 2. 12. Okay. So Q 1 by 2 plus 1 by 6. Now 4 into 3. Micro. Now you have to check, see that V1 and V2, somehow the V1 and V2 will make V. Now V1 will be Q by C1, 18 upon 2. Okay, V2 will make 18 upon C2 is 6. Now if I add this V1 and V2, see that makes 8, that is 12 volt. Okay, so this is how we can say. Now see here, voltage, smaller capacitor, voltage will be more, and larger capacitor, voltage will be less. So they are, you can say why, because V is Q by C. It is inverse proportion. It is inverse proportion. Now how we can do it fast? Charge remains same. Q is equal to CV. Suppose here charge voltage is X, then here it should be 3x. Why? Q is equal to CV should be constant. 6 into 1 x is 6x, 2 into 3x is 6x. So now see this will be 3x plus x is equal to 12. 4x is 12, x is 3 volt. See what is x here? Voltage across 6 microfarad capacitor, that is 3 volt, that we have easily calculated. See numerical you have to solve by the first principle or by the solution. Now and voltage across, this is voltage across 6 microfarad capacitor. Now voltage across 2 microfarad capacitor is 3x. See now that we have obtained. So what we can see here is a faster method. Okay, when we will solve MCQ, we can calculate like this. Why? Because series connection, charge remains same. Accordingly, we can calculate. Basic principle we need to keep in mind. Now see a 100-volt battery. Okay, see we have to calculate charge across each capacitor. Okay, now first we calculate equivalent capacitance of the system. Now here it will be parallel, it will be NC. N is equal to 3 and 6, 80. Now 2 microfarad. Okay. Now see the voltage supplied is 100 volt. Now C equivalent will be C1 C2 upon C1 plus C2. 2 into 18 upon 2 plus 18. When 18 to the 36. Okay, 18 by 10. Now see the total charge. Q is equal to C equivalent into B. See, battery voltage is how much? 100 volt. Microfarad. Now see what is the voltage across this? V1 will be Q upon C1. Okay, 180 upon 2. Okay, and if we solve V1 plus V2 is V, V2 will be 100 minus 90 to be 10. Okay, now series connection charge remains same. Series connection charge remains same. So here will be 180 micro coulomb. But parallel the charge is divided. So charge across each of the three will be divided